Morning, everyone. Okay, so I am audible, right? Okay. Am I audible, students? Just write in the chat box whether I am audible or not. Okay. Okay, fine. Okay, then let's start our class. Okay, so what were we discussing last class? I think we were discussing about the sedimentation tank, right? As per I remember, we were doing sedimentation tank numerical. Okay, for circular and the rectangular one we were doing. So today we will be uh, doing, okay. So today we will be doing your, after your sedimentation tank, it is your like secondary treatment process, okay. So secondary treatment process, this one we will be discussing about your aerobic attached culture, and it is through your biological filtration of sewage, okay. So like the effluent, okay, so the effluent that comes from your primary sedimentation tank, it contains about your 60 to 80% of the what organic matter, which are unstable in nature, and they are present in the sewage, okay. So this like the colloidal organic matter, okay, which passes the through the like primary clarifiers, okay, without settling there. So this organic matter, colloidal organic matter, it has to be removed for for by further treatment, okay. So this further treatment of sewage, it is like known as your secondary or biological treatment, okay. And it is carried out what, by changing the character of the organic matter, and it converts the unstable organic matter into a stable forms, okay, like what, nitrates, sulfates, etc., by oxidation or nitrification. Okay, so like the character of the organic matter in that present in the sewage, it can be changed by different methods. There are different methods for changing the character of the organic matter, and those are like filtration and activated sludge process. So in that filtration, we will be dealing with your trickling filter. So we will be discussing it today. Okay, activated sludge process, it won't be possible to discuss today because trickling filter is a bit long. So two processes are there. One is your filtration and the other one is your activated sludge process. So this secondary treatment process, so these are basically designed to work on what, aerobic bacterial decomposition, okay. So they are designed to work on the aerobic bacterial decomposition. So like this is like because of the fact that what basis aerobic decomposition, they does not produce bad smell and gases, okay, because they are the organic matter are oxidized in presence of oxygen. So it is known as aerobic decomposition. So like it doesn't produce any bad smell and gases, and these are produced by anaerobic decomposition. And because of these aerobic bacteria, they are more active than your anaerobic bacteria, and everyone is always interested in the active ones. Okay, so this in aerobic bacteria, those are very much active than your anaerobic bacteria. Okay, and this aerobic bacteria, their rate of working, it is like they are three times more than that of your anaerobic type of bacteria, and it is done at what, 30 degrees Celsius. Okay, so in the this biological treatment units, the main aim and the main aim is to produce what, a suitable environmental condition. Okay, a suitable environmental condition, those help in what, stimulating the growth of the aerobic bacteria. So those help in the growth of the aerobic bacteria. Okay, so now the filter units, that are those are used in the secondary treatment plant. It consists of what, open beds of coarse aggregates. Okay, so there are in your filter units, what is present in the cell secondary, like filter units in the secondary treatment, it consists of open bed. Okay, so it consists of open bed, and what is the bed consist of, it is of your coarse aggregates. Okay, so over the coarse aggregates, the sewage, okay, it is sprinkled intermittently. So it is sprinkled, the sewage, it is being sprinkled over your coarse aggregate bed. Okay, so the contact surface for the, like the, for the growth of the aerobic bacteria, it is provided by the aggregates in the bed. Okay, so and the aeration, it is provided by nature. So here the it is a contact surface between the sewage and the aggregates. Okay, so this the effluent, this from this like filter units, it is settled out in what, secondary clarifiers. But in the other hand, I was talking about this activated sludge treatment unit. So this activated sludge treatment unit, it consists of what, aeration tanks. Okay, aeration tanks of long detention period, in which the activated sludge is mixed and aerated. So in activated sludge process, basically what has happened is that there the this oxidation, it is the oxidation happens in the aeration tank. Okay, and a part of the sludge, or a part of the effluent, sorry, a part of the effluent, it is being transferred to the settling tank is there, and from the settling tank, a part of your sludge, it is again, it is taken back to the aeration tank, and a part of the sludge, it is being disposed of. Okay, so basically, okay, just give me 2 minutes. Okay, 2 minutes. Okay. Sorry, I got an emergent call. Okay, that's fine. Okay, then what where I was up to? Okay, so in the activated sludge process, what happens there? Like there is an aeration tank and the oxidation of the organic matters, or it happens there. Okay, and the effluent from the aeration tank it goes to the secondary settling tank. Okay, and in there. Where in the bottom of the secondary settling tank, your sludge is formed. Okay, and in that sludge, a part of that sludge is again goes back to the aeration tank for recycling, and one part of your effluent it goes directly. It is considered as your waste sludge. Okay, so basically. Activated sludge process we will be learning in our next class. So here we will be basically dealing with your trickling filter. Okay, so the filter part we will be dealing it here in today's class. Okay, so so there you see if for the biological treatment attached system. Okay, attached system there are four types of your like different types of filters. Okay, so number one is your contact pads. Okay, number one is your contact pads, number two is your okay that contact pads these are used as your at your very small plants. Okay, and these contact pads filters they have almost become very obsolete nowadays and these are not used. Okay, now the next one is your intermittent sand filters, so those are also used as your smaller plants. Then number three is your trickling filter, so it is most commonly used in modern days. So in we will be discussing mostly about the trickling filter only. Okay, and number four is your miscellaneous type of filters. Okay, those are used under like special circumstances in particular projects. So we will be directly going through the to the trickling filter. Okay, so you see here the conventional trickling filter and their improved forms known as high rate trickling filters are now almost universally adopted for giving secondary treatment to sewage. So the improved version of your this trickling filter. It is known as a conventional trickling filter. Okay, and it is most used, commonly used nowadays for giving secondary treatment to the sewage. So here these filters, these are called also known as your percolating filters. Okay, or sprinkling filters consist of tanks of coarser filter media over which the sewage is allowed to sprinkle or trickle down by means of spray nozzles or rotary distributors. So here basically in this trickling filter, the bed surface is your coarse aggregates. Okay, there is coarse aggregates in the bed surface, and like this it has some spray nozzles. Okay, it has some spray nozzles, and through this spray nozzles your the sewage it is being trickled over your surface bed. Okay, so that's why since the sewage it trickles down over the surface bed, so it is known as your trickling filter. And this water it also it has some rotary distributors also. Okay, so now what I will do, I will show you one video. Okay, I will show you one video, and then you can little bit see, or you can understand, or you can imagine the trickling filter plant. Okay, so you see that video. Okay, and then we will discuss it again.
pump to the trickling filters, the mechanical and physical process of primary treatment are concluded. The next step is biological treatment, which is known as the secondary treatment process. The wastewater that is pumped from the primary effluent wet well to the top of the two trickling filters is spread evenly across the surface of the filters through revolving pipes known as distribution arms. These arms have holes known as ports. The trickling filters are 86 feet in diameter and about 46 feet tall. You can see these structures as you drive along Route 1 between Cook's Corner and Main Street. The biological treatment process happens when microbes consume organic matter in wastewater and convert it to carbon dioxide, water, and energy for their own growth and reproduction. The microbes grow on a plastic cross-flow type media, which looks like a honeycomb. The media in each filter is 22 feet deep. The cross-flow design enables more biological treatment to be accomplished in a smaller space because of the increased surface area. The surface area in each filter is 3,830,000 square feet, the equivalent of 80 football fields. More area means more room for microbes to grow. The slimy growth on the trickling filter media is called a zooglial mass. It is where the microbes such as nematodes, stalked ciliates, and rotifers live and break down the organic chemical bonds in the waste. When the biological treatment in the trickling filters is complete, the microbes have eaten their fill. They are fat, dumb, and happy. The microbes will die from lack of oxygen. They fall off of the trickling filter media and exit the bottom of the filter as a solid called humus, also known as secondary sludge.
Okay, so you have seen the video. Okay, so now I think
नमस्कार दोस्तों, कैसे हैं आप?
just wait.
Pump to the
Now
trickling
you
filters,
understand,
the
I think,
mechanical
here. Just
revolving pipe.
okay. This part you can see, right? This one, and this one. These are your rotary arms, okay, or rotary distributors. And this one, there are small nozzles here, spray nozzles you can say. So from where this sewage it is coming out, okay. So that one is your spray nozzles, and this one is your bed, okay. Below it there is a force aggregates, it's there. So basically this is a trickling filter plant. Okay, so now next video you see about the working principle of your, like how it's designed. So you see this video, just wait.
Do you want to start your own business with these three advantages? Number one, you don't have
Trickling filters are biological reactors within wastewater treatment plants, which are used to remove organic matter and/or ammonia from wastewater. Compared to the activated sludge process, the microorganisms are not suspended in the mixed liquor, but they are attached to a fixed bed surface. Nowadays, the fixed bed surface is usually provided by structured plastic fill media, but in the past, rock, gravel, and hardwood was also used. Wastewater from primary clarifiers is continuously trickled over the first layer of plastic fill media using a rotary distributor. While wastewater is traveling down to the bottom of the trickling filter, a cross-corrugated pattern within the plastic fill media ensures a good water-air mixing. Trickling filters are operating under aerobic conditions, but mostly without the use of forced ventilation or aeration. Instead, the tower shape of trickling filters causes that air is sucked inside the tower over slots at the trickling filter bottom. This effect is also called chimney effect and results from air buoyancy, which occurs due to a difference in indoor to outdoor air density, resulting from temperature and moisture differences. For the design of trickling filters, three components are very important: the support structure, plastic fill media layers, and the rotary distributor. The support structure has to withstand high vertical loadings of up to 50 kilograms per cubic meter, 3 pounds per cubic feet of plastic film media, plus up to 250 kilograms per cubic meter, 15 pounds per cubic foot for attached sludge and water inside the film media packs. At the same time, the supporting structure must leave enough space for sludge collection and removal and to avoid blockage of plastic film media channels. Therefore, the support structure typically consists of PVC stanchions, FRP grating and slope corrector plates to adjust for bottom slopes. The plastic film media layers must provide enough surface area for attached growth of microorganisms, ensure a good water and air mixing, as well as withstand structural loadings. Typical removal rates for trickling filters are between 5 and 20 grams BOD per square meter plastic film media surface area per day and 1 to 2 grams ammonia per square meter per day. Plastic film media is available in different types with various specific surface areas. As higher the surface area, as more microorganisms are available and as better is the performance of the trickling filter, but at the same time as higher is the risk of clogging. During the lifetime of a trickling filter, the plastic film media will be exposed to many different outer impacts, such as water, UV radiation, changing load requirements, foot traffic, and cleaning procedures. In the beginning, these effects will be barely noticeable, but over time, especially the bottom and top layer of plastic film media start to deteriorate. With increasing damages, the air and water distribution within the trickling filter gets worse and worse, so that the performance of the trickling filter starts to decrease. When the bottom layer compresses and the top layer shows cracks and broken channels, it's time to exchange the plastic film media. To maximize the lifetime of plastic film media, the layer distribution must be properly designed. The material thickness of plastic film media foils can be varied depending on the structural loading requirements. Therefore, for a long time, 30 years, the bottom layer should be reinforced, followed by average to low material thickness film media layers and finished with a high material thickness, reinforced top layer. Finally, the purpose of a rotary distributor is of course a good water distribution, so it's also used for plastic film media flushing. For an even spray pattern, a certain distance between top of plastic film media and rotary arms must be determined. As the spray area enlarges with increasing distance from the central shaft, more spray nozzles have to be placed at the end of the rotary arms, compared to the beginning of the rotary arms. Finally, the amount of water trickled above a certain plastic film media area per minute influences the flushing effect, also known as spoolcraft or SK value. As higher the SK value, as thinner is the layer of microorganisms attached to the plastic film media surface. The goal is to maintain enough microorganisms for BOD and ammonia removal, but to prevent excessive microorganism growth and clogging of film media channels. Thanks for watching, and if you like our 3-minute tutorials, please subscribe and don't forget to give a thumbs up.
Just wait. Okay, so you have watched a video, and now you can imagine the like the trickling filter plant. Okay, you have seen how does it look and how this trickling filter it works. Okay, so now um, now this one is your like the typical section of your trickling filter plant. Okay, you have seen the video in the video. Okay, so what are the types of your trickling filters? So there are like two types of trickling filters. Okay, one is your conventional trickling filters, and the other one is your high rate trickling filters. So this conventional trickling filters, or it can be also you can say that ordinary trickling filters, or standard rate or low rate trickling filters. So like in your the high rate filters or the like this high rate trickling filters, it has the same functions like your conventional trickling filters. Okay, and also they have the same constructional details, but the difference is that the provision made in the high rate trickling filters. Okay, it is in them is for recirculation of sewage to the filter. Okay, so their recirculation of sewage through the filter can be done by pumping the filter effluent to the primary settling tank. Okay, and repassing it to the and the filter. Okay, so this is the basic like difference between your conventional trickling filter and the high rate trickling filters. So there are different merits and demerits also of your trickling filters. Okay, so like it's written here, so many different merits and the demerits are also written here, disadvantages are also given nicely. So let us read out one or two three points. Okay, so like in the trickling filters, the rate of filter loading is high, and the smaller quantities of filter media are used for installations, and lesser land areas are also required. Okay, so and the effluent that is obtained from the trickling filters, it is like nitrified and stabilized. Okay, so and they can remove your like 75% of BOD and about 80% of your suspended solids also. And the working of trickling filters, it's very simple and does not require any skilled supervision. So all this and many are there. Have your self cleaning. They are self cleaning. So and the mechanical wear and tear is small as they contain less mechanical equipment. So many are there. Okay, so you read out the merits and demerits of your trickling filters. And the differences between your conventional and high rate trickling filters is also important. You can note it down. You can write 5 to 6 points. Okay, based on each characteristics, you write 5 to 6 points from here. Okay, so conventional and high rate trickling filter. This one I will share with you by today. Okay, and previous notes I have already shared. So this one I will share it by today. Okay. So today we have done about the trickling filter. So next class, that is tomorrow, we will be doing your like activated sludge process. Okay. And after we do activated sludge process, your treatment part will be finished. Okay. So okay, let me take your attendance. Roll number 51.
Present, ma'am.
Okay, 52.
51 is present, ma'am.
52 present.
Yes, ma'am.
Okay, 53. 54, 55, 56, 57, 58, 59, 60, 61,
Present, ma'am.
62, 63, 60, 63 is present, okay? 64, 64, 65, 66, 67,
Yes, ma'am.
okay, 68,
68 is also present, ma'am.
okay, 68, 69,
Ma'am, 66.
okay, 66, 67, 68 present, 69, 70,
Present, ma'am.
okay, 71,
Present.
72,
Present, ma'am.
73,
Present, ma'am.
74,
Present, ma'am.
75,
Present, ma'am.
76, 77,
Present, ma'am.
78,
Yes, ma'am.
79, 80, 80, 81, 82,
Present, ma'am. 81.
okay, 82,
Present, ma'am. 82.
okay, 83,
Present, ma'am. 83.
83, okay, 84, 85, 86, 87,
Yes, ma'am.
87, okay, 88,
Yes, ma'am.
89, 90,
Present,
90,
ma'am.
90, okay, 91, 92,
Present, ma'am.
92, 93,
Yes, ma'am.
okay, 94,
Present, ma'am.
95,
Yes, ma'am.
96, 97,
Present, ma'am. 97.
98, 99,
Yes.
100,
Yes, ma'am.
101,
Present, ma'am.
102, 103,
Present, ma'am.
104, 103,
Yes, ma'am.
okay,
103.
103, okay, 104, 105, 106,
Present, ma'am.
okay, 107,
Yes,
one,
ma'am.
okay, 108, 109,
Present, ma'am.
109, 110, 110, triple one, 112,
Yes,
113,
ma'am.
112, okay, 113, 114, 115, 116, 117,
Yes, ma'am.
okay, 118, 119,
Present, ma'am.
120, 119 is
Yes, ma'am.
present, okay,
Yes, yes.
120,
Yes, ma'am.
okay, 121 of absent. Okay, quickly I'm reading out the present ones, okay? Anyone is left out? 91 is present, okay? And anyone else is marked absent? Who is there?
Ma'am, 114.
114, okay. Anyone else?
Ma'am, 101.
101, okay. It's given present. Another? Anyone else?
94, ma'am.
94 is present, okay. It's present, marked present. Okay, then I think others I have given. Okay? And see you tomorrow. Okay, I'm ending the meeting.